Hi everyone, this is part 4, and in part 1, part 2, part 3 I have covered everything, but this example will actually boost your confidence. It has a lots of possibilities. When you will do a dry run, then actually will understand the code if you are able to find all the possible paths from 0 to 6. So first of all, I will say that you should try by yourself. You should follow the code that I have shared in the part 2 video. That this is the code, right? Like, following this code, you need to find all the possible path from 0 to 6. If you are able to find all the possible path, it means you are really good at try running this code, and you will actually find a confidence in yourself. So first of all, try with yourself. Now I will be doing it for you, right? So I will not go deep into that detail. I will start from 0, that is our source node. I will be wrapping this code all over the dry run, right? So I started having 0 as a source node. So, and my source is 0 and destination is 6, right? So 0 is not equal to 6, so this will not work. Then I have to set, initially all the values are set to the false, and now I have to set 0 as true. So 0 as true. Now I will check into its neighbor. So 0's neighbors are 1 and 3, 1 and 3, right? Now I will check which neighbor is false. So 1 is false, so I will do a recursive call making 1 as the source node, right? So I will do a recursive call. So when I do a recursive call, I will came to this point. Now 1 is not equal to 6, so this will not work. Now I have to set 1 as true, right? Now I will check into 1's neighbor. So 1's neighbors are 0 and 2, right? Now I will check which neighbor is false. So 0 is true, so this will not work. Now 2 is false. You are able to see 2 is false, so we are able to do a recursive call making 2 as a source node, right? So we will make 2 as a source node, and we came to this point. 2 is not equal to 6. This will not work. Now we have to set 2 as true, right? 2's neighbors are 1, 3 and 5, right? Now check which neighbor we are into this point. Now we have to check which neighbor is false. 1 is true, we can't do anything in this path. 3 is false, yeah, we will be able to do a recursive call making 3 as a source node. So we came to this point. 3 is not equal to 6, we have to set 3 as true, right? Now we have to check into its neighbor. So 3's neighbors are 0, 2 and 4, right? Now again we came to this point. Now we have to check which neighbor is false. So 0 is true, this will not work. 2 is also true, this will not work. 4 is false, right? So we are able to do a recursive call making 4 as a source node. So source become 4, 4 is not equal to 6, this will not work. Again we have to set 4 as true. Now we have to check into its neighbor. So 4's neighbors are 3, 5 and 6, right? Now again we have to check which neighbor is false. So 3 is true, this will not work. 5 is false, yeah, we will be able to do a recursive call making 5 as a source node. So we are at this point. Now 5 is not equal to 6, this will not work. We have to set 5 as true, right? Now we have to check into its neighbor. So 5's neighbors are 2, 4 and 6, right? So we have to check which neighbor is false. 2 is true, this will not work. 4 is also true, this will not work. Now 6 is false, right? So we will be able to do a recursive call making 6 as a source node. So we are at this point. Now 6 become equal to 6. We reach at the destination. So we got our first path, that is this, right? So 0, 1, 2, 3, 4, 5 and 6. So we got our path 1, that is uh, 0, 1, 2, 3, 4, 5, 6. We got our path 1. Now we are at this position, this is true, so we will return back to this point 5. Now we are into 5 and we are at this point in 5 and we are done with all the neighbors, right? So we will mark 5 as false. We will mark 5 as false and we will backtrack to 4. Now we are into 4 and we are at this position in 4. We are done with 2 neighbors. There is one more neighbor remaining, that is 6. Now we have to check either it is false or true. So it is false, we will be able to do a recursive call. Now we set 6 as source node and we are at this point. 6 again equal to 6. So yeah, we again got our second path, that is 0 1 2 3 4 and 6. So the second path is 0 1 2 3 4 6, right? Now again we do the same thing. We are at this point, so we will set return true and we goes to this point. Now we are into 4 and we are at this position. We are done all its neighbor. Now it's time to set 4 as false. So we set 4 as false again. Now we are done with all the neighbors of 4. Now we came to point node 3, right? So we are at this point in node 3 and we are done with all its neighbor. Now we came to this point again, we have to set 3 as false. Right now, since we are done with all the neighbors and this we are at reach at the last point, so we will backtrack to 2. Now we are at 2, we are done with 1 3 and still there is one neighbor remaining, so we check if it is true or false. So 5 is false, so yeah, we are able to do a recursive call making 5 as a source node. So 5 is not equal to 6, so this will not work. Now we have to set 5 as true again, right? We do a recursive, we will check into its neighbor. So 5's neighbors are 2 4 and 6, right? We will draw like this. So 5's neighbors are true and now we have to check which neighbor is false. 2 is true, this will not work. 4 is false, yeah, this will work. 4 is false, we will do recursive call making 4 as a source node. So we are at this position, 4 is not equal to 6, so this will not work. We have to set 4 as true again. Now we will check into its neighbors. So 4's neighbors are 3 5 and 6. So 3 5 and 6, right? Now see, now again we have to check which neighbor is false, right? So 3 is false, so yeah, we will be able to do a recursive call on 3. So we have to set 3 as, first we have to set true. So what we are doing, like first we are setting true and false, then neighbor, then again resetting. So we are at 3, we have to set 3 as true. We have done this. Now we have to check into 3's neighbors. 3's neighbors are 0 2 and 4, right? So we have to check which one is false. So 0 is true, can't do anything. 2 is already true, can't do anything. 4 is also true, can't do anything. Now we are done with all the neighbors. So now the third thing, that is resetting. So we will reset its value to false again. Now we are done with this. Now we will go to this 4 again. Now we will do the recursive call on the remaining neighbor that are false. Check 5 is true, we can't do anything in this part. 6 is false, yeah, we will do a recursive call making 6 as a source node. Now 6 is equal to destination, so again we got our third path, that is 0 1 2 0 1 2 3, yeah, 0 1 0 1 2 5 4 6. So 0 1 2 1 2 5 4 6. We got our third path, right? Now again we are done with this. So we are done with this, like we already said 4, we are done with neighbor. Now it's time to reset it. It's time to reset this 4 to false again, and we will backtrack from this. Now we are at 5, we are done with its two neighbors. Now the third one is remaining, so we are at 6. Now we know that 6 is already equal to destination, so we got our fourth path, that is 0 1 2 5 6, right? So the fourth path is 0 1 2 5 6, that is 0 1 2 5 6. Yeah, now we are done with all the neighbors, so we have to reset 5 to false again. Now we backtrack to this point. We are done with all the neighbors of 2. It's time to reset 2 to, we have to reset 2 to false again. Now we will go to this point. Now we are at this point. We are done with all the neighbors of 1. Now we have to reset 1 as false again. Now we are at point 0. We are done with this, sorry, we are done with this, and we are not done with all the neighbors of 0. So we are done with first neighbor. Now we have to check with the 3. Now we have to check it with the 3, right? We started with 0, we are done with 1, this is done. Now we are at 3, we are at 3 again. We have to do the same thing. We are at 3, setting 3 as true, so 3 will set true. Now we will check into its neighbor. So 3's neighbors are 0 2 4. Now we have to check which neighbor is false. 0 is true, we can't do anything. 2 is false, yeah, we can do anything, we can do something on it. So now we are at 2. So what we need to do, we have to do 3 steps again. We have to do a setting on 2. So we have to set it to true. Now we have to check into its neighbors. So 2's neighbors are 1 3 5. Now check which neighbor is false. 1 is false, yeah, 1 is false, so we will set it as a source node, and we will do a recursive call. Again we have to do the three things. We have to set it to true, we have to check its neighbors. So its neighbors are 0 and 2, right? We have to check which neighbor is false. So 0 is true, we can't do anything. 2 is also true, we can't do anything. We will return back, and when we are return backing, we have to do a resetting. So we will reset it to false again, right? Now we are at this point, we are done with its first neighbor. Now the two neighbor is remaining, that is 3. Now we have to do a setting. So we will again, no, we can't do any setting because it is already true, so this will not work. Now 2, right? 2. Now its third neighbor is 5. We have to check whether it is true or false. So 5 is false, so yeah, we will do a recursive call. Again we have to do a setting, like we have to make it to true, then check into its neighbor. So 5's neighbors are 2 4 6, right? Now check which neighbor is false. So 2 is true, we can't do anything. 4 is false, yeah, we will do a recursive call on 4. Again we have to set it, first we have to set it to true, then check its neighbor. So 4's neighbors are 3 5 6, right? Now check which one is false. So 3 is true, we can't do anything. 5 is true, we can't do anything, right? Now 6 is false, so we got again our fourth path, that is 0 3 2 5 4 6, 0 3 2 5 4 6. So fifth path, sorry, this is fifth path, 0 3 2 5 4 6. We got our fifth path. Now we will backtrack from this point. Now we are done with all the neighbors of 4. Now we have to do a resetting, so we will mark 4 as false again. Now again we are at 5, and we are done with its two neighbor. Now the third neighbor is 6. Again we got our sixth path, that is 0 3 2 5 6. So sixth path is 0 3 2 5 6, 0 3 2 5 6. Yeah, this is right. Now again we do a backtrack. Now we are done with all the neighbors of 5. Again see, we are done with 5's neighbor. Now we have to do a resetting, so we will reset it to false again. Now we will backtrack to this point. Now we are done with all the neighbors of 2, so we have to set 2 as false again. Now we are at 3. We are done with two neighbors of 3. Now the third is remaining. We have to check is it false or true. So 4 is false. Yeah, we can do a recursive call on 4. Now we have to set it to true first. Then we have to check into its neighbor. So 4's neighbors are 3, 5 and 6, right? Now let's see which neighbor is false. 3 is true, we can't do anything. 5 is false, yeah, we can get a path from, we can do a recursive call on 5. So now what we need to do, we have to set it to true again. Now check its neighbors. So 5's neighbors are 2, 4, 6. Check which is false and true. 2 is false, yeah, we can do a recursive call on 2, right? Now 2 neighbors are 1 and 3. 1 is false, right? We can go to its neighbor, that is 0 and 2. 0 is true, so we can't do anything. 2 is, no, first of all, like when we entered into 2, we have to set it to true, right? First true, then check its neighbor. So 2 is already true, we can't do anything. Sorry, 0 is true, 2 is also true. Sorry, like when we are, first of all we need to set 2 as true, then we will check its neighbor. So 2 is also true, we can't do anything. Now we are backtracking with 1. So when we are backtracking, we have to set it to false again, right? We are at 2. Now we are done with its first neighbor. Now check the second neighbor, that is 3. Now 3 is true, so we can't do anything. Now we will backtrack. Before backtracking, we have to set 2 as false again. Now we are at this point 5, right? Now we are done with its first neighbor. Now check second. 4 is true, we can't do anything. Now the third neighbor, that is 6. 6 is already 6 is false, so we can do a recursive call, right? But 6 is equal to destination. When it is equal to destination, we will simply return from that point. Again we got our 7th path, that is 0, 3, 4, 5, 6. 0, 3, 4, 5, 6. So 7th path is 0, 3, 4, 5, 6. Now we have to return back from 5 again. Since we are done with all the neighbors of 5, now it is time to resetting 5 to false again. Now we are at this point 4. We are done with 2 neighbors. It is still remaining the third neighbor, that is 6. 6 is false, and we have to simply return whenever we are getting a destination. So we got our 8th path, that is 0, 3, 4, 5, 6. 0, 3, 4, sorry, 0, 3, 4, 5, 6. So we got our 8th path, that is 0, 3, 4, 5, 6, right? So you see this code actually, there are 8 paths that we did not got it manually, but we got it by this code only and with the dry run. I hope if you do a dry run of this code, this is more than enough to give you the feeling of how the code works and how you need to get to the right answer, right? If you are able to get all the path, then you are damn sure that you are good at the concept, right? Do it once again if you are not able to get all the path, and do it like this only. Otherwise you will be not able to find all the path. Maybe you are able to find the left path, maybe you are stuck in this. So just make it like I have made it, and just do these things. Like our code is mainly depending on these things: first setting it to true, then neighbor checking, then resetting it. Okay, so that's all for the video. Thank you.